Well, hello friends. Welcome back to the program. Today we are going to work on something that has been an issue for a long time in Ladybird, which is image tags that refer to an SVG file. So on modern websites, such as Shopify, they often use SVG images linked by IMG elements, and we just don't support that at all at the moment. We can render SVG if it's inline in the HTML, but like these things right here, they are just IMG elements that refer to some external SVG file. And yeah, I think this is something that I've mentioned like 100 times that, oh yeah, we need to implement that as well, but we never actually did it. So that's why many modern websites tend to look like this in Ladybird, where there's just like a logo and some big illustration or something missing. But as you can see here, if we actually open it in a separate tab, then we can render this SVG pretty well, actually, I would say. We just don't know what to do when it's in an IMG element. Okay, that didn't quite work out. All right. Anyway, so what we're going to do today is we're going to hook up some kind of mechanism where image elements can load external SVGs and then render them into sort of an independent context where you can't put scripts or stuff inside of the SVG and have them interact with the rest of the document, because you're not supposed to do that. And then we need to make sure that they can be rendered at different sizes, because SVGs are scalable vector graphics, obviously. So we can't just render like one bitmap and then be happy. Rather, we have to have some kind of mechanism where you can query it for an arbitrary size bitmap. So that's kind of what we're going to do today. And let me actually get CLion started. And then let's start somewhere. Let's start with, I guess the first thing that we need to do is to make sure that images can load something that isn't just a bitmap or an animated bitmap. So what image elements currently load is this thing that we call a decoded image data. And it represents sort of the single or multiple frames of a bitmap or animated bitmap at the moment. And the HTML image element will download data and then decode it, and then create a decoded image data object from the decoded frames. And then this thing is the thing that image element keeps around and uses to render, uses to layout. So I think what we're going to do is we're going to make this thing pure virtual, and then have two subclasses, basically, one for bitmaps or animated bitmaps, and another one for SVG. And then once we have that, we can then create SVG decoded image data when we're downloading an SVG. And then inside of that thing, we can have all the logic for like parsing SVG and creating a separate layout context and rendering the thing. And we'll put all that in its own class, basically. So first thing we'll do is just make this thing pure virtual. So I guess actually maybe this thing can become like a decoded image data. This will be like an animated bitmap. Animated bitmap decoded image data. That's kind of what it is. And it will inherit from decoded image data. This will be final. Then I think the SVG variant is not going to have animation frames in the same way. Once we do SVG animations, we'll have to implement that some different way. Anyway, we can't just cache like all the possible animation frames. So I think here we're just going to simplify this interface until it is as basic as possible. Let's see. Okay. And I guess this becomes protected and something like that. Okay. There's a start, and then these fellas would all become, I think we're going to put this in a separate file actually, just for that clarity and separation of purpose. So this would be animated bitmap decoded image data. Okay. So HTML animated bitmap decoded image data. Let's yoink it and put it over there. Okay. Oh, I don't have copyright set up. That's okay, I'll just copy from here. So decoded image data. This isn't really part of the HTML specification, so I'm a little bit like annoyed already that it's in the HTML namespace, but it's okay. It's in service of HTML stuff. So let's just make sure that this thing has the same old interface. And why can't I do that? It's an abstract class. Oh yeah, because I have to actually make a bunch of things virtual. And we'll have to say that we are overwriting all kinds of things here. Cool. Wait, what? Decoded image data is an abstract class. Oh, this is, I forgot to update the name here. There we go. Okay, so let's see if we can just get this refactor to build. It will be easier to then extend it with the SVG version of the same thing. So here we are just going to I guess actually we can just do this for all of it. Is that good? Okay. Cool. And let me just get a build running here. All right, and then in the base class, we really just need like default constructor and destructor at the moment, I think. Nothing fancy. All of this stuff can go away. We might put more stuff here later, but I think now we're fine with that. And then whoever was actually instantiating this right here. So this is an HTML image element where we actually create one of these things. So we will just update this thing to say it will use the animated bitmap decoded image data for now. Yeah. decoded image data. Okay. So point of what we're doing now, we're just giving ourselves an extension point. And let's go ahead and commit here. libweb. Make decoded image data an abstract class. The existing implementation moves down into a new subclass called animated bitmap decoded image data. Purpose of this refactoring, purpose of this change is to create an extension point where we can plug in an SVG renderer. All right. Of course, we're going to plug in our very own SVG renderer, but we have to have somewhere to put it. Okay, and then I think now I just started thinking about how we communicate the size of the image to the layout system. Because I think at the moment when we lay out an image, we just we get the current bitmap. So if there's like an animation going on, we just ask for the current image bitmap. And then we just say like, oh, the intrinsic size of the image in the layout context is the width and height of the bitmap. Or if there is no bitmap, because we haven't loaded it yet, the intrinsic size is 0 by 0. And I think this is obviously not going to work for SVGs because they don't necessarily have an intrinsic size like that. I think they have, in practice, what most of them have is an intrinsic aspect ratio, but they don't necessarily have a width or height. So I think what we want to do here is we want to reorganize this code a little bit. Maybe that's easier to do before we add something, before we add the SVG thing. So let me just look at that quickly. So if the image provider, instead of giving you the bitmap, so image provider, by the way, is an interface that's implemented by two things at the moment. It's image element and object element, because both of them can provide an image to the layout system. So they both implement image provider. But I think this implementation here is lacking. So we're just going to add a, what do we call it? Like intrinsic width. Yeah, we're just going to add this kind of API where the provider can optionally give you width, height, and aspect ratio. 0 or more of these could return a non-empty value. And then we will implement these image provider. Okay, so how do we implement these here? Okay, HTML image element. So I think what these are going to do is they're just going to check if we have a current image So like if we have image data, if this current image request has data, then return we're just going to ask the image data for its intrinsic information. And if we don't have image data, we can return empty. And then the image data is the decoded image data. And the API here was called natural width. I don't know why I called it that. Yeah, we're going to change that, call it intrinsic. I almost spelled that right. Intrinsic. I'm going to call that intrinsic, and and it also needs to be able to provide an intrinsic aspect ratio. Okay, so now we have, I think that gives us the API that the layout system needs. Let me just make sure that we actually have the same API here. And for these, it's easy to calculate all these things because we just look at the first frame in the animation, or if it's not an animation, then just the frame or the bitmap. And it's really straightforward. So we just take here the intrinsic width value divided by intrinsic height value. Why did you not like that? Oh, because I didn't say flow at. Flow at. Where was I supposed to go? Here. Float. Okay. And cool. So how would that look if we use that? Let's see. So instead of querying, instead of getting a bitmap and trying to figure out intrinsic size from that, what we'll do is, I guess we can just ask the image provider directly now. So if the intrinsic width has value, then set intrinsic width image provider intrinsic width. Can we just do that? No, we cannot. Oh, that's kind of interesting because these are CSS. It wants CSS pixels. I guess it wouldn't hurt anybody to say CSS pixels here as well, actually. That would probably be fine. Then the values would just work everywhere. Of course, the ratio still has to be float because it's a ratio. And then we just have to update this in a bunch of places. And then where is CSS pixels from, I wonder? Pixel units, that's the one. Okay. So CSS pixels. And can we do something like that? No, that we cannot do that. What am I even trying to do? I just want to do this divided. Oh, of course I have to cast a float. I didn't even think of that. Copilot just did it automatically. I was about to do an integer divide and or I guess it wouldn't be an integer divide anymore actually because I have CSS pixels. Okay. Wait, so if I divide two CSS pixels values, I get CSS pixels out, of course. So is what I really want to do not cast a float, but rather do divide and then dot value on it? Is that fine? Okay. All right. Not exactly sure what I've done here. We need to look at not image provider, decoded image data. No. Here, image element. Okay. Okay. Got a little bit jumpy there. Let's see. Oh, and then we can't build because object element. We need to at least add the overrides to object element so that it's buildable. And then it will fail at link, but we can at least, I was gonna say we can at least get a full build. Use of undeclared identifier CSS pixels. What? Oh, image provider needs to include. Sure. So now that we have compatible types, I think this thing here wants a CSS pixels optional, so that actually simplifies this. We can just say like that. Set intrinsic aspect ratio. And if we do all that, we don't need to do any of that. So that's pretty nice. Okay. And then it's up to the image provider to figure out what are the intrinsic width, height, and aspect ratios. Great. Now we are missing object element stuff. So let's go and add that so that we can actually link. Here, I guess. So optional CSS pixels. So object element doesn't use decoded image data yet. We do need to port it to use that somehow, but this specification only describes how to load HTML image elements. It doesn't actually tell you how to load images in object elements. I guess the implication is that you load them the same way, but it doesn't actually, the specification algorithms are not really factored in a way that makes reuse possible. So that's something that we're going to have to come up with ourselves. Alternatively, improve the specification and then implement what we come up with there. But I think we'll ignore that right now. So point is, it's using the old image loader mechanism. So we're just going to hook into that here. And say if the image loader has a value, then what is the API for the size? We ask for bitmap 0 width. Yeah, so something like that. And for the width, for the height, and for the aspect ratio, we just divide those two. And that wants to be a float. Okay, so let's see that the world still loads web pages, even complicated ones. Yeah, seems all right. Or is it not all right? Okay, it seems to hang there. That's a little concerning. Why did it hang? Okay, it hangs after a while. What are you doing? You are painting background. Okay, that's concerning. Probably something became monstrously large. And now it's just taking forever to paint it. I'm guessing I probably screwed up I mean, this here is definitely a screw up because I have to cast a float if I'm going to divide two integers. And what did I do in the image element? I just forwarded it to image data, which does bitmap width divided by bitmap height. And those are integers. Okay, so I was just nonchalantly saying I don't need to cast, but I actually did need to cast. So let's cast. Okay, I think that's probably what got screwed up. We got like a busted integer divide there, which ruined the aspect ratio and screwed up layout so that we got some huge thing that then we got stuck painting. Yeah, that seems to have at least made it stop hanging, so that's good. Okay, so does this still pass tests? Let's just double check that. But assuming that it does, I feel pretty positive about this change. So let's commit. Yeah, that's good. So what do we say here? We say make image box ask image provider for intrinsic size and ratio. This paves the way for image provider to have something vector based underneath. All right. Cool. So then maybe now we can actually add the SVG decoded image data thing. So let's do that. SVG decoded image data. Maybe that should live in the SVG directory, actually. That seems like it would be slightly more appropriate. So decoded image data. All right. And let's do this as well. And then for all of these, we will just, for now, we will just replace animated bitmap with SVG. You go in SVG, web SVG. And what are we gonna do with this thing? Well, we'll figure it out. We will figure it out. Oh, it's an unattractive ligature. Is that looking right? Don't particularly like the way that looks. I guess it looks nice when you have a comment like this, but it looks pretty awkward when it's part of a comment block. Actually, I never thought about that. Maybe that would be my first bug report for the Berkeley mono font. Anyway, ignoring that. By the way, if Neil is actually listening to this video, I know that Neil, who makes the Berkeley mono, sometimes watches my videos. So Neil, if you are by any chance listening, then I don't know what to do here, but this doesn't look super great when they're like this in a comment block. They're kind of lopsided. Anyway, love the font. Let's get back on track. So actually, let me just double check that I have. Yeah, ligatures are on. That's what's causing it, right? Yeah. Otherwise, they don't do that. Okay, let's get back on track. So this thing is not going to have frames in the same way, I think. So we'll get rid of the frames concept. And when we create one of these, we are just going to have, as our input, we're going to have like a byte buffer with an SVG file, basically. So we'll just say like encoded SVG. And this needs to be qualified. Sure. Okay, so we're not going to have frames. I don't know what we're going to be passing to the constructor yet. We'll figure it out, but there are no frames, no loop count, no animated. I think for these kind of things here, we will just say frame count, just a 1, loop count, no loops, animated false. These things we're going to need to figure out. Frame duration, whatever you ask, the frame duration can just return 0 here. And then we say, fix me support SVG animations. That would be a project. Okay. So bitmap and the intrinsic size stuff is really the stuff we need to implement. Also, I'm noticing now that the bitmap API is not exactly what we need, because we need to be able to render the SVG at an arbitrary size. And it just, here we just ask for a bitmap. So we kind of need to tweak this API so that it can be asked for any size. And then for raster images, or for like animated bitmap images, we can just return the same bitmap always. But for SVG, we can make you a new one at a rasterized at a better size if you ask for it. Okay, so all of this gunk. And all of that gunk. Yeah, I don't know exactly how we're gonna solve all this, but we'll figure something out. Bitmap. I think maybe the first step here is we're just gonna stub this thing out. So the intrinsic width will be 0. 0. Aspect ratio can be 1. Okay. Just want to see that we can get something that builds. Okay. I think we will do this as its own commit, and then flesh it out in subsequent commits. Stub out SVG decoded image data. New. This class will implement isolated SVG rendering. Purpose, SVG rendering. Yeah. Layout and rendering. So what was I saying about bitmap? Right, the API for bitmap is not really ideal for SVGs. So I think we're gonna tweak that before we continue too far. So we'll say that like you can ask it for a size. If we change the API to look like this, but if you don't ask for it, you'll just like ask for an empty size. So like 0 by 0. Then graphics size. And for this API, you can just, yeah, it doesn't, the animated bitmap decoded image data. Animated bitmap decoded image data. It will just ignore that and just give you the bitmap at the current animation frame. Yeah. Okay. And here. Wait, where do we actually use this? So this would be when we're painting an image. Image paintable. So we have an image in the paint tree, and we are painting the foreground, and we're not rendering it as the alt text because we actually have some kind of image. So here we're asking for the current image bitmap. So I guess what we really want to do here is ask for the current image bitmap at a specific size. So I guess I want the context rounded device rect because I'm going to paint this image rect. I'm going to paint this. Okay, I'm just going to yoink this, put that here, and then ask for it image rect size to type int. Something like that, and then make the current image bitmap API also work in that way, that it takes an int size. Okay, so it gets a little bit convoluted, but basically when requesting a bitmap for rendering or for painting, the painting system will provide the ideal size, and then if we can produce something at that exact size, then we'll do that. But otherwise, we'll give you sort of the best we can do. So the image provider needs to have that, yeah. Okay. Image paintable. Good. Okay, so that seems fine. Did I break something now? Image element. Oh, I should probably make that a default argument so that you can keep using it the old way if you like, especially when you're, yeah, that's fine. If you use it, if you don't pass a size, we can just give you like whatever we currently have. So like the latest cached version that we have. I think that's going to be fine. Image provider also needs graphics size. Okay. Okay, this feels sound. It's a bunch of architectural prep work today, but sometimes it's like that when you don't really have the foundation in place for doing something. You just have to put these pieces first so that you can put the house on top of that. Okay, so now tweak image provider API, bitmap getter, and for bitmap getter, take optional int size, I guess. Yeah, int size. Is int size the right thing? Yeah, because we're going to give you a bitmap back. So that it's going to be an int size. The bitmap will be, of course, in device device pixel size, I think, because we can't have a bitmap in CSS pixels. Optional size argument, size. This allows the painting subsystem to request a best fitting size. Request a best fit. What am I trying to say? It allows the painting subsystem to request a bitmap with the exact size needed for painting, instead of being limited to just give me a bitmap, which was perfectly enough for raster images, not for vector graphics. All right. Okay. So now that we have this, and presumably everything can still load web pages, nothing falls apart. Then we need to actually do something here. So what I was thinking is that we are going to create a sort of an isolated little miniature context. So its very own DOM document, its very own browsing context, its very own its very own little invisible browser tab, essentially, which the outside world can't see or interact with, but we will have that here, and then we will render the SVG inside of that context, and then just reach through all the layers and say, hey, can you paint into this bitmap? And then hopefully that will then allow us to get a bitmap out of this whole thing. So in order to build a context like that, I think we need to start with browsing context group, I want to say. Or no, we want to make a top level browsing context, actually. So browsing context, create a top level browsing context. That's what I want. For that, I need a page. Okay, so I need to make a page also. Page is going to be, so page, the page class represents roughly a browser tab. It's kind of the closest thing I can think of. It doesn't directly map to something in the spec, but everything, all the frames and subframes and everything belong to the same page. So everything within this tab belongs to the same page object. And the page sort of has the subframe tree, or the browsing context tree, hanging off of it. And we're going to have to make our very own page. So what do we need to provide to make our very own page? A page client, of course. Right, we have to make a page client. So we have to make our own thing here. So it's going to be a little bit of a hassle, but we will just suck it up and say SVG page client. And I think it needs to have a path back to its page, but I think we can't assign that until, yeah, we have to make the page client first. Okay. Make SVG page client. Can I make that? And then make the page with the page client. And then page client page is page. And then I can pass you there, and then we are on track. Okay, so here we're gonna continue here once we actually finish up this thing. We have to implement a bunch of virtuals here. It's gonna be a bit messy. Some of them are straightforward, just, you know, return your page. The page client, by the way, is sort of the way that we communicate with the outside world from the web engine. So inside of the web engine and the HTML code and the CSS code and stuff like that, if you want to talk to the user interface layer, you can't just reach out and call stuff in the UI layer, because the UI runs in a separate process. So the page client is sort of the interface that we have for speaking to the UI on the other side of the process boundary. And then we have all of these things here that you can call. So as long as you have a pointer to your page, you can call through the page client. And on the other side of this, there's somebody who is normally somebody who knows how to talk across the process boundary. But in our case, this is not going to talk across the process boundary. We are just going to swallow all of these calls except the bare minimum. It seems like we are required to provide a palette. That is a hassle and a half, actually. I think I'm going to be a little bit cheesy here and say I'm gonna remember the host page, and we're gonna get the palette from the host page. So it won't be a completely isolated context, because if you wanted to use like system colors inside of the SVG, we can only get the system colors via the host page, because that's how we get the current system palette. Maybe that should work differently, but for now, let's do it this way so we can at least get to it. It's a little bit awkward, but we'll call it the SVG page, actually, just for clarity here. Okay, and then here we can just return host page client. Yeah, so we just forward that request to the host page client. Screen rect, I don't think we need to, there's no reason for it to be able to figure out how large the screen is. The device pixel to CSS pixel conversion ratio, I think we do want to communicate, because if you zoom, the page, then we need to know what the pixel ratio is, device pixels per CSS pixel. Yeah, we'll let you forward that one, and the preferred color scheme as well. Okay, so there are a bunch of these actually that we need to forward through. But paint, we do not need. Navigation requests, blah, 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 link covering, all of this stuff can just fall on deaf ears. That's fine. Okay, and SVG page client. Wait, what's wrong with that? Overrides. Oh my goodness, none of these say override. Cool. Maybe they don't need to say override actually. Yeah, this class is a bit messy and a bit too large. It would be nice if it could be smaller, but maybe I don't need to actually do anything about these. I think I needed a request file maybe. Do I have enough? I'm missing paint. Okay, sure. I'll get that. All right. Okay, let's see if this works. So make SVG page client, and then we need to actually have the host page then. So we'll have to take that when we create one of these things. Host page, and then the SVG page will be the page that we just created. Okay, so in theory, we now have our very own sort of isolated context. In theory. Will this work in practice? Who knows? We'll find out. So then we need to parse. So how do we normally parse? Like parse document loading. Okay, so if the MIME type is image SVG plus XML, then we normally just throw it through an HTML parser and run it. That seems straightforward enough. This is not going to be perfect or 100% correct or spec compliant or whatever, I'm telling you right now, but it will be a first step towards getting something that works kind of, and then we can move towards making it better, of course. But sometimes you just got to start. So I created a top-level browsing context, but I need a document. I need a document. How do I make a document? I forget. Libweb dom. I need a document to be able to give to the parser. So document, create, and initialize. Okay, so dom, document, type, HTML, let's say. Maybe here was, somebody was calling this, presumably creating a document. Yeah, right here. Okay, so this is what we want to do. So we need a set of navigation params. Where do we get navigation params from? Here, somebody just gives them to us. Cool. Okay, so can we find an example? Yeah, this looks good enough. Response. Let's see, load HTML. Oh, this is kind of similar to what we want to do. We have a string and we want to load it up. So I guess maybe I can just do this, like make a fake response. Maybe that's good enough. Let's try this. And then I don't have to plumb the actual response, which might leak information from the outside world. I don't know. We'll figure out if that's necessary later. But right now, let's just make a fake response. So we need to include something for that. Thank you. And URL. I do need a URL, I guess. Seems like something we could Okay, so let's take a URL also. Okay. And then incomplete type, navigation params. Okay, browsing context we just have there. Okay, then we make a document. Cool, 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 cool. So if we got this far, which we'll see if we actually get here, but if we got here, then we should have a DOM tree that we could dump at this point. So let's see if we can do that. Data is the encoded SVG. What did I call it? Oh, I didn't call it anything. Oh, we can just call it data then. That's fine too. Okay. So can we get all the way here? Somebody has to create this. So an HTML image element, how do we know to create this thing, I wonder? So currently we just unconditionally create an animated bitmap decoded image data after calling the image codec plugin. So I think this SVG image, I don't have the MIME type here. So I just have a URL, and maybe we can plumb the MIME type down to ourselves, but for now, let's just be lazy. That's exactly what I wanted to ask. Base name, can I do that? Okay, so if it's an SVG image, then let's see. Okay, so this will be one code path. Okay, so if you have an SVG, then how do we actually SVG decoded image data? How do we get that stuff into one of those? So result SVG decoded image data, create from data. I also need the page. What am I in? Image element. Okay, so here, from here I can actually get to the, can I get to the page directly from here? Document page. Okay, I can get to the page that way. I think I'm gonna verify that it's non-null, otherwise this will just get very confusing. I need the URL. Oh, I have that right there. Great. And the data. Okay, and if that doesn't work, then I'll just dispatch an error event. And maybe we'll log something here like fail. Yes, thank you, Copilot. That's exactly what I wanted to say. Okay, I don't have a VM here. Oh shoot, how do I get to VM? I guess good enough. Okay. I am perhaps a bit too ambitious. Image element. What did I miss? Conversion function. Oh, it just needs a dereference. That's fine. Okay, so let's get an SVG that we can test with. Let's use that tuple logo. All right. Let's get this. We'll call it tuple SVG. All right. SVG as img.html. All right, here we go. Moment of truth. What will happen when we try to what will happen when we try to do this? Web page crashed. Ooh, okay. But we printed something. This does look like an SVG, albeit wrapped awkwardly in an HTML document, which I guess is not really what we want. I think we may need to parse it with an XML parser if it has like that XML version thing at the top. If it doesn't, I think we can use an HTML parser. I'm not sure exactly like what the exact rules are for parsing an SVG like this arbitrarily from the web. That's something that we can totally figure out. But in the interest of plowing ahead right now, let's just do like the easiest, most obvious ugly thing, which is to let this happen and then just rejig it. So like we just take this, yoink it, throw away this stuff, make this be the root of the document, because that's what we want in this case. And then we're crashing at some point. Decoded image data. Maybe we should just figure out where we're crashing, just in case it's something very important. It's crashing in image element 599. Oh, is that the unconditional dereference that I just did? Image data. Wait, what? Why is that crashing? Image data. Oh, I never assigned image data up here. Oh, that's my bad. Yes, like that. Okay. Okay. This is actually remarkably successful so far for what it is. I was expecting a bit more trouble. Okay, so we are at least loaded. And we have an image box right here, although it has content size 0 by 0 because it doesn't know what's going on here. We just have a DOM. We haven't done anything with it yet. Okay, so let's rejig the DOM. Fix me. This is hack till we figure out how to actually parse SVG separate. Okay, so now we're just going to find, I guess it will always be the child of the body because the HTML parser automatically sets this up for you if these things are missing. So the first child of the body that is a SVG element, we can just grab that. So like the SVG root is the document, but no, that's almost what I wanted to say. You're close. First child of type. Like that. Can I get that first child of type? Just need to include it. Okay. Nice. And then we will remove that from its parent. And then we will take the document first child and remove that from its parent. This is some serious DOM surgery we're doing right now. You're not supposed to do things like this, but this is a huge hack. Perform some DOM surgery to make the SVG root element be the first child of the document. All right. Yes, that's precisely what I wanted to do. That must succeed. And then let's see if we can dump the tree here. Because if we do that, then we will have a just the SVG as its very own DOM tree. And it works. Cool. Okay, so now that we have that, how can we paint this? I guess, well, let's make a helper. So we'll make a helper, we'll call it render. Render SVG to bitmap, is that what you're telling me? It's not actually not a terrible API for that. But yeah, that's actually kind of a nice API. Okay, render SVG to bitmap. Fine, let's do that. And let's have our very own cache internally as well. Yeah, that's exactly what I wanted. Thank you, Copilot. Okay, so that thing does not need to be a reference. Case size. And actually, the bitmap itself, you know, the more that I think about this, let's just not think about making a public API for that right now, even though it is really tempting. I'm going to make a, just going to say something like this, maybe. Render in size. Yeah, let's not worry about public API at this point. So what do these things do? So the bitmap here will say, if we don't have a bitmap or bitmap size is not the size being requested, make a new bitmap with the right size. Don't have a propagation path at this point. Then render into the bitmap. Actually, I guess we can do this. If we have a bitmap and we're good, then we can just return the bitmap. Otherwise, make a new bitmap. Something like that. Okay, and then, so how do we render? In order to render, we have to layout. Okay, so after we've constructed this thing, we're still in the factory function here, right? Yeah, we're still in the create function. So we want to instantiate this thing, and we need it to have a pointer to, well, I guess a pointer to the document at least. And this thing is not on the GC heap, so we'll just use a handle. DOM document. And you know what? I'm gonna be a little bit friendly here, and also have a pointer to the root element. Strongly typed for convenience. Okay, and then that'll be good. Okay. And I'm just realizing that somebody has to own the page and the page client that we created. So I think we need to pass that on here as well. Page client. Document. SVG root. Okay, so this guy needs to take can you take all those items? Page client, document, and SVG root element, let's call it. Okay. Why can't I do that? Calling a protected destructor. Page client, destructor. Wait, what? Non-null own putter page, SVG page client. Okay, fine. We'll do that, and then we'll have to declare it like that, but it's no big deal. Okay. And thank you. Okay. All right, so now that we have all that stuff, how can we use it to render? So we have the document now. So at that point, I guess we have a size. So we're just going to tell the document's browsing context that the viewport is now 0, 0, size width, size height. Okay. And then we're going to say update layout. And at that point, in theory, we should be allowed to paint. I'm gonna dump the layout tree here and see what it looks like, just because I'm very curious at this point. I need to include the viewport. But we should have a layout tree, although I'm not sure the metrics will be good, but at least, okay, not good enough. Bitmap allocation failed, apparently. Oh, I guess if it asks for an empty size, so if size is empty, like 0 by 0, then we should probably not give you a bitmap. And we shouldn't try to allocate one either. Okay, so problem is now that we're never going to try to render because in the outer layout tree here, the image box is 0 by 0. Because we said, that's what we tell it, like, oh, we are 0 by 0. So if we told it that we were 200 by 200, obviously we have to actually figure out the dimensions, but if we told it that, then it would be 200 by 200, and we still don't get still don't try to lay out though. Let's see. Bitmap. Just out of curiosity, are we still asking for 0 by 0 here? Bitmap 0 by 0. Okay. All right. So who's asking? Who is asking? That would be I would think that would be the image paintable asking. Current image bitmap. Image rect size to type int. Current image bitmap. Are you not forwarding that? Oh, I forgot to forward the information to the bitmap request. Okay. Okay, so that's good enough that we can actually get to the point where we do a layout. That's fantastic. Content size 200 by 200, blah, 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 blah. Okay, so let's see, this goes in the, I was going to say this goes in the preceding commit, or which commit was that? Image provider, bitmap getter, take optional size argument. Let me just amend that real quick so that it goes in the previous commit. Okay. Plumbing it all the way through. All right, so the next step is to paint then. So in order to paint, we need a paint context, which we can just create ourselves if we have that included. Then where's render? Right here. Okay, so painting, paint context, apparently not in the painting namespace for some reason. You need a painter. Okay. And you need a palette. So page client palette, sure. And you need device pixels per CSS pixel, which we can ask for. Cool. Once we have that, yes, that's exactly what I want to do. Thank you. And then we just call paint all phases, and look at that. It works. Oh, that's so cool. Okay. It doesn't scale because we hard coded the size, but yeah, it's supposed to be like this, right? So let's see how we get it to that point. But this is a great first step. So let me just say border 1px solid black. Yeah, it's 200 by 200. In order to do that, I guess we should, let's commit here. Just so that we have a first commit with web. Render SVG as image into an isolated page top level browsing context. In order to separate the SVG content from the rest of the engine, it gets its very own page client, top level browsing context, etc. We do awkwardly. Fortunately, we do have to get the palette and CSS device pixel ratios from the host page. So for now, maybe that's something we could refactor in the future. Note that this doesn't work visually yet, since we don't calculate the intrinsic sizes and ratio for SVG images. That comes next. Okay, so the intrinsic stuff for SVGs I just did in the previous video, although that was in the layout layer. Now we want to kind of do the same thing, but we need to do this before we have a layout tree. So we don't have the convenience of looking at a fully formed layout tree. Instead, we have to, I think we have to like run style computation and then look at the computed style and determine from that. So let's see how we would do that in practice. Or, so it would be something like document update style, and then I need the root element style computed CSS values. That should be a, that should exist at that point, because once you update style, you should have root element style. And then we should be able to get the width value, not just property, but actually it's a size value. And if it's a length and the width value length is absolute, if we have an absolute length as the width, absolute length to px. Otherwise, we don't have a size. I think this will be good. And note that update style does nothing if style is already up to date. So it really is like update the style if it's invalid. If it is valid, it won't do anything. So calling these two in succession does not do double work, just to clarify. Here, let's see. So if we do those, that gives us, at least in theory, let's see if it still runs. Ooh. Oh, shoot, look at that. Okay, so let's say that we don't know the ratio. Wait, how is it doing that? Okay, so the ratio, interesting. So does this, I have to look at the SVG actually. The SVG doesn't have width and height. Wait. Oh, so it's just falling back to 300 by 150, right? That's the bizarre, is that what that is? It's like the bizarre default in the specification. Yeah. For whatever reason, I'm sure there's some historical artifact reason for this, but like in the old CSS spec, it says, if you can't figure out the width for an image, it's 300. If you can't figure out the height, it's 150. And for some reason. And here, we can't figure it out because the SVG doesn't have width or height specified, so they're just auto. But what we do have is we have a view box, as you can see here. So from the view box, we can define the intrinsic aspect ratio. So that's what we have to implement here. And that's also something I did yesterday. So let's just, this should live somewhere better eventually, but I'm going to, at the very least, link to this stuff from here. Just to be nice, so that anybody who wants to improve this, probably me, but if somebody else does, then they know where to go. Obviously, we should find a way for these two mechanisms to share code instead of having separate implementations. The problem is just that one of them has a layout tree and the other one has a DOM tree with the resolved style. So they need to speak some common language so that they can have the same type of primitives to do the logic on. Okay, so here, same kind of workflow. We need the root element style. Oh, actually, I guess we can just check. What was the thing doing here? We get computed width and height, and then we do some shenanigans with that. So actually, we can just query for the intrinsic width and height, I think. If we have both. No, these should be divisible without casting. Or am I crazy? That gives you a CSS pixels and I can dot value that. Cool. Otherwise, we're supposed to look at the view box. So the view box logic was, if there's a view box, just get the width divided by height of the view box. Right. So if the root element view box has value, then return root element. Okay, let's write this in a slightly nicer way. View box width divided by view box height. Okay. Hey, look at that. That's cool. Okay, so what happens if we go to the tuple website? Oh, shit. It just loads. That's so cool. Man, I was putting off dealing with this for a year at least, I feel like. And it's actually not that tricky. I just needed to actually do it. So that's good. See if it fixes the ones on Shopify as well. Okay, we have a little problem. 76. Temporary result is error. Okay, 76. A pen child is failing. Why would that fail? Pen child pre-insertion would fail. Okay, so pre-insertion validity probably failed. Wonder which of these situations. Let's just dump out the tree so we'll see like what's the last tree we try to append in before we die. It's gonna be something goofy probably. Okay, so it looks like that. Wait, that's a bit weird. Why does it look like that? Document first child removed. Does that not work? You're not letting me remove the first child? Is there a better way to do that? Like remove all children. Maybe that's what I want to do. Okay, that seems to have been more forgiving. I'm not sure why. I think maybe the problem is just that remove is like a DOM API. So it has to behave a certain way, and remove all children is not a DOM API. It's just something that calls child remove internally, but I'm not sure. Well, I guess it removes everything from the thing. Why would that be more forgiving? I don't know, but I'm not going to think too much about that because this is a gigantic hack anyway, the little DOM surgery thing here. So I'm not going to worry about why one thing works better than another. But wait, I wanted to look at the SVGs. Let's see the SVGs on Shopify. Because I know there are some. These are supposed to load. And they do. Oh, shit. That's so cool. I mean, they look janky, but that's just because of our path rasterizer, which needs work, but it does load. That's so sweet. I think these are SVGs as well. Probably these ones. Yeah, there's a bunch of these going on here. And oh, and I know another page that I kept being annoyed that we couldn't see the SVG, which was the Steam store. There's an SVG up here. The logo is an SVG. It doesn't look perfect though. It looks a little clipped. Now why would that happen? So let's see, store steampower.com. Let's see. What's going on here? Is it that it has an intrinsic size and then we just use that? I don't know, but let's not get distracted with that right now. We have to leave something for the future. Wait, let's see. Let's this can go in the preceding commit. The dumps don't need to be there because that's going to get real noisy. Okay, so calculate intrinsic width, height, and aspect ratio for SVG as image. Spelling. Okay, intrinsic size and aspect ratio. This finally makes SVGs show up. Image show up visually. That is really rad. I should mention we should find a way to share this logic with SVG box, but since they work on that will require some finesse, since they work at different points in the layout paint timeline. Okay, so what is the problem with the Steam one? Let's just stash that here. So wget Steam SVG. Let's make a Steam SVG as IMG. Okay, yeah, sure. IMG SRC Steam SVG. What's wrong, buddy? Okay, and what's supposed to happen is, okay, so it should look like that. Interesting. Wait, so what's the problem? Why are we clipping it? So Firefox renders it like that, but presumably there's something going on here. So the image, oh, the image itself has a width and height on it. Okay, so let's try that. So width 176, height was 44. And let's set some background color here, like, I don't know, 888 or something. Okay, that was not so beautiful. Okay, so now it looks crappy. Cool. And here it actually, so why does that happen? Why does that happen? So I guess when we have width and height, so this SVG had width and height, right? Let's see. It has intrinsic width and height attributes on the SVG root element. So that means that it will report those to our layout algorithm, and then it will just lay it out at that size, I guess. Is that what happens? Let me dump out the... I'm already dumping out the layout tree. So what does the layout tree say? Steam SVG layout. Okay, so we have a viewport is 176 by 44. And then my SVG box is 355 by 89. And was that the intrinsic size? 356 by 89. Yeah, that is the intrinsic size. Okay. So that's going to be the issue. That in our little thing here, in our little isolated world, the viewport gets the right size, but the SVG box, because it has a width and height on it, our CSS layout system just says, oh, this has a width and height. Those are its width and height. And that that will screw up the layout. I just have to move my phone alarm forward a little bit here, just a second. Okay. So I think in order to solve this, I'm going to do a little bit of a thing when we lay this out. So when we're laying out the viewport, I think if we're laying out a viewport whose first child is an SVG box, then we know that it's like a standalone SVG document, and then it shouldn't follow normal layout rules. Instead, this thing should just be the size of the viewport. I think that's sane, or it's like a bit of a hack, but it kind of solves this problem. And this type of document will not occur otherwise, because it won't occur in HTML because the HTML parser will create a DOM that cannot produce this kind of layout tree. There's probably a better, nicer way to do this, but let's approach it this way for now. So let's see. If the root first child and the root first child is SVG box, then we do one thing. Otherwise, we do classic layout. Okay, so here, it's not exactly what I want to do, but I do kind of want to do this. I need to include some file. Okay, and then I just want to lay out the inside of the SVG. Context, create independent formatting context for the SVG root. And then I just want to run that with the same available space as I have for the viewport. Will that work? I wonder. It's a bit strange, but that does work. Yeah, exactly. So now, when we are laying out the viewport, and the viewport has this as its first child, then we will just do a special treatment and lay it out with the same size as the viewport, same available space as the entire exact viewport. And let's see if it works in context. Come on now. Yes. Ah, that is so cool. Okay. Oh, didn't I think Hacker News recently changed their little logo thing to an SVG, I want to say. This little thing. And it shows up. That's great. Let me double check that it's actually an SVG. I know it was like a GIF or whatever for forever, but that is an SVG, and we can just paint it just right. Cool. Man, I am stoked. This is so good. Why was I putting this off? Okay. So here, this deserves a little bit of a note. If we are laying out a SVG, standalone SVG document, we give it some special treatment. The root SVG container gets the same size as the viewport. And we call directly into the SVG layout code from here. Yes, I think that's good. Let me see. I had some dumps here I wanted to get rid of. Let me just amend that to the preceding commit. There we go. libweb. Always make standalone SVG document roots the size of the viewport. Make standalone SVG document roots the size of the viewport. Yes. We have to special case these, otherwise our normal CSS layout algorithm will see that some SVG roots have width height assigned and make those the used width / height. When used in an SVG as image context, the viewport must be the authoritative size. Authoritative root size, yes. The outermost viewport must be the authoritative root size. Cool. Very, very cool. Just gotta look at these things again. I bet that this makes things show up many places on the web. I wanted to just think of something, and now I'm just blanking, but I remember Mozilla, for example, they have, yeah, look at these. These are SVGs. And do they scale? They scale. Ooh, that's so cool. And we are dumping out the tree because I didn't rebuild. Okay. Oh man, this is so sweet. Yeah, that's awesome. And I think this is not perfect. Like, it could be better in many ways. One way is that we actually shouldn't need to create the intermediate bitmap representation at all. Like, we could refactor this so that Paint Context knows how to paint an image provided directly somehow, and they could coordinate that, and then we could paint directly without an intermediate bitmap. That could be something awesome. I don't know, but at the moment, I think this is really sweet. Let me just see what this looks like in another engine, just so. Yeah, I mean, our SVG, it's clearly loading the SVG. Then we're not necessarily rasterizing it beautifully, but it is there. So cool. Oh man. This is so much fun, but I think we need some kind of a test for this. But what is an ideal test here? I guess for now, let's just make a simple SVG and then make a test that just makes sure that it gets the right dimensions. That's sort of the best we can do at the moment because of our layout systems, or our layout test system. So let's see. We have a simple, or let's even call it rectangle. Okay, so we'll make an SVG. Viewbox can be 200 by 100, let's say. And we will make it 200, 100. It doesn't really matter. It just needs to be something in there. Green. SVG as image. And here we will say rectangle. Oh, SVG as image. Okay, so if we, yeah, this test verifies that the aspect ratio is applied. It jitters a little bit when I resize it like this. I don't know why. The Y position is not completely stable, but I'm going to ignore that right now. And just do this. Because I really just need the simplest possible test. And this is really, really simple. Maybe I could make it even simpler by making the image be block level. Can I do that? Almost. I need to get rid of the new line. Okay. Yes. And if I change these, I mean, it doesn't even need to have anything inside of it. It's just nice that it does. Then the size is the other way around correctly. Yes, exactly. Oh, why don't we tolerate the file? That's interesting. I guess maybe because we don't set the XML and S. Or maybe we are like being too tolerant of bogus SVGs. Let's see. Oh, that makes Firefox is a little mad. That's interesting. Do I need to close the SVG? Are you mad about that? Okay, what am I doing wrong? Does it need to have like one of those things? Oh, it's so strict. Okay, I didn't realize that. I guess that's something that we should be more strict about as well. But as I was saying earlier, I'm not, obviously we're not parsing this strictly correctly. It's something that we should do, but we are throwing it into the HTML parser, which would be pretty lenient, but also produces a decently good result, at least for what we need right now. And then we can work on making it more correct. But as we can see here, it successfully loads an image and gives it a 1:2 aspect ratio, which is exactly what we want. So that will be our basic test for this functionality. So we'll take that thing and rectangle, I guess. Libweb layout. Okay, and then we're just gonna do that. And let's see if it succeeds here. Okay, did we actually? SVG as image passed. Cool. That's awesome. Okay, so it actually works. Add a simple test, very basic test for SVG as image. This mainly just checks that we load the file and learn the correct intrinsic aspect ratio from the loaded SVG. Cool. All right, this is going to be the end of today's video. We went a bit long, but I think we made great progress. So if you made it this far, thank you so much for watching, for hanging out. I hope you saw something interesting here today. I'm certainly very, very happy to have actually finally implemented SVG as image. I'm sure that there are some things we're going to discover are not great about this implementation, but at least now we have something. And immediately after I stop recording, I'm going to think of 1,000 websites to test this with, but for whatever reason, these are the only two that come to mind right now. Yes, so thanks for hanging out, and I will see you all next time. Bye.